Okay, this is TechTalk number 2. Traps for the unwary, a bit more about the dangers of comparison. We talked last time about visiting the dealer's room where you were presented with 2 loudspeakers, A and B, and you have to make a judgment between A and B. Recently, using part of our R&D budget, I went out and bought a number of competitive speakers, and the first thing I did is take them to the lab and measure them. So I got the frequency response charts, and then I sat down to listen to them. And I was actually genuinely surprised that although the frequency responses were in several cases really, well, poor, terrible even, they didn't sound anything like as bad as I would have expected from the frequency response. So, for example, a speaker that I would put my own name to had a frequency response that looks like that, this being decibels and this being frequency. A nice flat response with a tailored bass. But another loudspeaker which I compared, which had a response that looked something like, say, that, I would have expected, based on years of working to achieve this sort of standard, that would sound extremely coloured in comparison. And we talked about coloration and holes in the frequency response in TechTalk number 1. Actually, the comparison between these two was much more subtle than I expected, and that disturbed me a little bit, because the effort required to achieve this in terms of manpower and fine adjustments of the drive units and the crossover and component cost in the network is really very considerable. And this, this could be achieved in perhaps a 20th of the time of this level of refinement. So I wondered why this was even tolerable. Well, if you remember, in TechTalk number 1, we talked about the audibility of a series of a notch in the frequency response. Of course, this is decibels and this is hertz. So that if a hole was introduced into the frequency response of the loudspeaker, of the amplifier, of the music, of the cabling, whatever, so that at your ear there was energy missing in this band here, whichever frequency this is, if that was your norm, that was what you were familiar with, in comparison with the flat response, if you made an A-B comparison, this, as we discussed in TechTalk 1, this would sound highly coloured compared to this. Refer to that for more information. But that led me to investigating this a bit more deeply, and I found that actually the situation is even more complicated than this, because not only is one notch potentially inaudible, but so is a whole series of them. Which is quite shocking, because we, in audiophile manufacturing, presumably strive, I know I do, for the highest technical performance we can achieve, and yet it is a well-known fact amongst those that study this, that by the introduction of a highly corrupted frequency response in any part of the chain, including the loudspeaker, this may not be audible. In fact, you can try this yourself if you get a program like Audacity and you take some music and you punch a number of holes in it like this. Now, there are criteria such as the depth of these notches and how close they are together and so on, but that's another subject. And that led to another revelation, really, which is that not only if we introduce notches into the frequency response, they may or may not be audible, or they may be audible to the subconscious, but they are not audible to the conscious ear until you do a comparison with something that's flat. But the opposite is also true, that if you take the frequency response and you introduce a number of peaks in it, that compared to that may also be inaudible. depending on, and this is critical, how closely these peaks are spaced together, and of course how tall they are. And you can synthesize this quite easily with a graphic equalizer, which is typically a 31 band 1/3 octave box, which has sliders for each of the frequencies. A professional one would be 31 bands, and the center position is 0 for all of these sliders. And if the sliders are moved up in this direction, there is a boost, and if the sliders are moved down in this direction, there is a cut. So what we are saying in this case is that if we, to remain within the inaudibility bands, if every other one was boosted across the spectrum to give us a frequency response like this, even up to say 4 or 5 dB, it would be inaudible. In fact, it was actually shown by the research work that was done by the BBC that on certain types of music, dance or pop music, this actually sounded better subjectively than this, which is remarkable. So the point I want to make is that the comparison of two loudspeakers, A and B, is again by no means a trivial matter. The selection of which one is the flat one and the comparison process with the alternative is likely to result in the wrong decisions unless you are very structured in your comparison. And ideally you need to be armed with an understanding of what the frequency response is of these loudspeakers before you start the auditioning, so that you can make a mental allowance for the tricks that your ear is going to play. So that's it, that's part 2, and see you in part 3.